Hello guys. Today I'm going to talk about a unified visual approach to roles and mean value theorems. Rolle's theorem and mean value theorems combinedly state that if a function f of x is continuous on the closed interval, an interval in which the endpoints a and b are included, and differentiable on the open interval, an interval in which endpoints a and b are excluded, then the Rolle's theorem says that if f of A is equals to f of B, then there exists at least one point C where the derivative of the function is equals to 0. While the mean value theorem condition says that if f of A is not equal to f of B, then there exists at least one point C where the derivative of the function is not equals to 0. To visualize it, let us consider Rolle's theorem in the form of question. Consider a function x squared minus 4x plus 3. So we have defined the function and we define two values. A is equals to 1 and b is equals to 3. We check the value of the function f1 and f3. If both are equal, then the slope is 0 and the first condition is satisfied. To see it, we write f1, f3 and slope. So when we execute it, which I have already executed, we get 0, 0 and 0. So this 0 belongs to the case where we have found f1 and this is again 0 and the slope is due to these two values is 0. We see that the slope is 0. This means that there exists a point C where the derivative of the function is 0. To find the point, we take the derivative of the function and make it equal to the slope and then solve it. So for this case, we define another function which we make the derivative of the original function with respect to x. And then we solve the derivative function and make it equal to the slope of the function. So when we do that, we obtain a point x equal to 2. So we see that this point is the required point where the slope of the function is 0. That is, the derivative of the original function with respect to x is 0. The question is, can we see the it graphically? For this case, we Taylor expand the original function about x equal to c and copy the terms up to linear order in x. For this case, we series expand the original function and get the terms up to linear order. So these are the terms. We consider the first two terms and we write these terms here together with the function. So to visualize the situation where the function becomes constant and the slope of the function becomes 0, we plot the original function and the first two terms of the above Taylor expanded function. So these are the conditions. We apply frame and we apply the frame label, and this is a useful command to apply the labeling. And when we apply these commands, and this last command is the epilogue command, this command is useful to obtain the point where the tangent line touches the curve, and we can see that this tangent line is parallel to x-axis, and if any tangent line which is parallel to x-axis, then the slope, that is dy by dx, is equals to 0 in this particular case. That means the function becomes constant with respect to x-axis. On the other hand, if we consider the same function and change the value of b, then condition 1 says that if both are equal, then the first condition is satisfied. But if these are not equal, then the first condition is not satisfied. So to check the condition of the function at 1 and 2 and the slope of the function, we see that the value of the function at a equal to 1, we have 0, and the value of the function at a equal to 2, we have minus 1, and slope is minus 1. So therefore, the slope is non-zero and f of a is not equal to f of b. So to find the point, we write again the df of x is equals to df1x with respect to x, and we solve in the same fashion as we have done above, and we find the point x equal to 3 by 2. So to visualize it graphically, we Taylor expand the original function about x equal to 3 by 2 and copy the terms up to linear order in x as. So we copy these two terms. So we once again plot the original function and the first two terms of the above Taylor expanded function. But the difference here is that we now have the point 3 by 2. So we combinedly plot the original and the Taylor expanded function at C1 equal to 3 by 2. And when we plot the function, we see that the tangent line which touches the curve at point 3 by 2. So here you can see that 1.5 is the value of the 3 by 2. And at this point, this tangent line is not parallel to x-axis. Therefore, the slope is not equals to 0. Thanks for watching.